Okay, hi everyone. Welcome to this review of Wolfram language capabilities. Today we are looking further at new compiler capabilities. And Christopher is sharing his screen. And where do we start?
So this is sort of what so last time we started talking about this and then spent a lot of time talking about down value compilation. So we didn't totally finish this. The main thing that's still left to discuss though is the naming. So
Okay.
to review, I mean, basically what this is, it's in the same way that $pre is basically like, conceptually $pre is called, or $post, let's say, is called on every piece of output, but by default, it just doesn't do anything. These are various functions that, are conceptually called in various places, but most of the time by default don't do anything. And in the same way as $post, there's pretty much no reason why the user should ever call $post. It's only really useful to define. So that's basically what these are.
So $post is a creature of the main loop. So what is the analog of the main loop here?
Well, okay. There are various analogs. So in this case of onFree, this is the memory management system. So that's checking the reference counts. Or in the case of to and from expression, although these names might change, this is the system that creates the wrapper code that is like the glue between the evaluator and compiled data types and so on. So
but in that particular case,
systems.
what is it going to? So that to expression means it's coming from what in the compiler?
It means that maybe, right, I have some compiled type that's, who knows what, it represents a struct in C that's interacting with some external thing, or, God only knows what it is. And it's represented in some low level way that, and I basically, but for the purposes of compiled code functions, you'd like to be able to serialize that to an expression and deserialize it from an expression. So by default, when I call compiled code function, it compiles the main function, and it also compiles this wrapper that does that serialization. And so these are the functions that tell it how to do that serialization for user-defined types.
But you said it might be to expression, but what would it be fed? I mean, to expression would normally be fed a string.
Right. So that's why I'm okay. So ignore the right-hand side of these arrows here. Right. I mean, this is me sort of saying that as an alternative, I think that the easiest thing to do would be to have this thing called compiler interface. As an alternative, in some cases, there might be some top level functions that you could define instead. But I think this is kind of a bad idea. And in some cases, there's no top level equivalent that you would, you try. And these are all puns. Like, this is not actually to expression. This is something that's a little bit like to expression and so on. So ignore the right-hand side of it.
Calling it compiler hook or something.
Well, that's sort of the question. So, okay, hook is another term.
Compiler hook, yeah. It's a bit like Captain Hook.
Yes.
Well, I mean, okay. So again, can we get some sense of what the different event types are for the hook? You've got onFree.
Yeah,
I mean, I can maybe Tom can think of some
yeah, I mean, there might be some other ones like, shut down the compiler, or shut down this particular segment of code.
Or load the compiler or something is another one. Like, there are various libraries. There are lots of external libraries where, when you first load it, you need to call some init function, for instance.
Okay, so wait a second. So hold on a second. What declares this? This is when anything is freed. So somewhere inside the compiler, it's calling something. It's always wrapping compiler interface of, if you write the code, there's something that is doing the freeing that it would normally do. And then
so in this case, what it really is, it's like if I say foo equals, So let's say, this 1, 2, 3, let's say that's a packed array or something, it's some memory managed thing. Okay. Or it could be user defined type. More realistically, it'd be user defined type. If I say, foo plus 2, and then I call 4, something like that, right? So this foo doesn't get returned from this module. The point is, at some point, after this line, this foo is going to be, freed because it's not used anywhere.
What's the specific call that's going to be made then? So it's going to be compiler hook of on free of.
It's going to be there's going to be an invisible
function.
Call.
Right.
That'll be something like this.
Right. You just declare the function. You never call it explicit. You just declare the function.
No, I'm aware. I understand that,
yes.
Tom. I'm asking what is the thing that it would be doing if it were doing it explicitly?
Yes, this is invisibly what secretly happens.
Right. It would be a null function that that does nothing. A function with no body that gets inlined.
No, but what does it pass? The foo there. I'm
well,
still
it would pass a reference to foo that then you can then operate on. So let's say foo holds let's say you're doing some sort of network thing and you're holding a socket.
Exactly.
Then you would need to write an on free that closes the socket.
Correct.
Okay, so the on free will have something that is not just a single on free, but it'll be something that is an on free for this type and on free for that type.
Exactly.
Yes.
Okay,
but that's not the case for all of these.
Okay, but wait a second. So compiler interface. Oh, I see.
So when you define the function, you'll write a function declaration, and you'll write. Let me write one of these for on free. You'll write. You'll give it a type, and you'll say something like this. You'll say, okay, the type of this function I'm writing, it's going to have type. It's going to be a WebSocket.
Yeah.
And then it returns null, presumably. And then the body of it is going to do who knows what. Right. And so when this invisible function gets called, foo, in this case, it's a packed array, and it's going to call the packed array version. If foo were a WebSocket, then it would call this version, right? Just because that's how the type system works.
But so wait a minute. When you give a function declaration, normally, I'm very confused here. Normally, there will be a function declaration that would say the name of a function, and then it would give its body.
This is the name of the function.
Yeah, that's the name of the function.
You're allowed to have compound names like this.
Yeah.
Because you're just associating the function declaration to this compound thing, but
it's like this.
You could have just called that compiler interface on free as a symbol name, and then you could have a compiler interface to expression symbol name and all that. But then it's just a proliferation of symbol names. This just makes it.
Yeah, but okay, but the point is that this declaration for on free is for that specific type, and there could be another declaration for another type.
Right.
Correct.
And there's probably some generic polymorphic declaration that does the standard thing, whatever it is, which is probably a no-op.
Yeah, exactly. That's exactly how it is.
Okay, but are they all no-ops by default? Like to expression shouldn't be a no-op by default.
No.
Dollar post is a no-op by default. I mean, I think.
Right. Well, some of them probably something like to and from expression probably don't have defaults. So that if you try to return a type that doesn't have that, then you can't return that at the top level.
You can't compile the code.
Well, but the compiler will fail because you haven't defined a proper interface.
Right.
And more usefully,
who knows what the default interface should be.
Right.
The message would say, I can't compile this because there's no implementation of to expression.
Yeah.
Or from expression.
Okay.
Yeah.
Okay. So I'm slowly understanding this. So then the thing that is passed in, so function declaration is passed a pure function and the name of this thing is on free applied to that type. And
yes, I mean, this is where I put my declaration, my code for on free that operates on a WebSocket.
Yeah.
Right.
So, and this is equivalent to something like this. If you that's how function declarations work. So this is the function name. These are the arguments, etc. Yeah.
Well, or you could say compiler interface of on free equals function of blah, blah, blah.
Sure. Yes. But I'm just trying to make it clear. This is the function name.
Yes. Okay, so hold on. So normally a function declaration would, if it wasn't one of these special utility type things, what would it normally look like? Would it say function declaration of f, comma, typed, blah, blah, blah?
Yeah, it's exactly the same.
No, but
It's just
what
that
would
in this case, the function name happens to not be a symbol. It happens to be some bigger expression, but otherwise it's identical. And you can already in other places, you can define function names that are not symbols. So
you can do that yourself. You could do this. You could invent another whole thing where you didn't use symbols. Use one symbol in these strings if you want. It's
sure.
It has to be a symbol
it's legal
somewhere.
syntax.
It has to be a symbol somewhere. So,
Yeah.
But
yeah.
Well, why does there have to be? Because it's still an assignment.
It's just the way the compiler is set up right now. I mean, at some level, it's rare that you'd never really want to be able to define, two of hello as a function. Right?
Yeah,
this is not very useful.
Yeah,
correct.
Right. But you could have a kind of an index, a parameterized collection of functions, f of 1, f of 2, f of 3, all with function declarations.
Sure. I mean, this is exactly the same as what we do with library function above, where you'll call library function of, and then you'll give the name of your C function, or malloc of blah blah blah. Right? It's exactly the same thing. It's a parameterized set of functions.
Okay. But the difference here is that from within the compiler, it is calling back into the on-free thing for this particular type.
Correct.
Yeah.
So to be precise, when you declare this type, there's by default a bunch of code that's automatically generated, and in the body of that code, like for when the object is freed, there's a hook that's going to try to call this function.
Right.
So there's just automatically generated code that happens because you declare when you declare a type product. There's a bunch of code that just gets.
What does that declaration look like? The type declaration one that you have at the top there.
Well, we have.
No, you right above your function.
There's one right here. Yeah. So what was the question?
No, so I mean, what you're doing there is that's a type declaration of foo prod. Why does it have product as the first argument of type declaration?
That's the type of
it's a type product,
kind of declaration that it is. It could
it's
also
a
be
type of type declaration.
Yeah, which is usually called a kind, but yeah.
Kind of type declaration. Okay, that's the declaration of the type, and so this function declaration. I mean, couldn't one imagine function declaration of compiler interface being its own separate function that's called something like, compiler interface declaration?
That was actually one of the original designs, but I don't think it makes a ton of sense.
Similar. It's just a function.
It is a function. It's like, it's just a convention. That's all. And I think, in this case, because there's nothing different about them, they're just function declarations.
They're just functions. Exactly.
They're just using a convention is a perfectly reasonable way to do things.
I think this is equivalent to the fact that you write $post equals instead of having a function that's called set post function or something.
Right.
Yeah, exactly.
Yeah.
Okay.
Or just in something like C++, really all you're doing is if you declare a destructor, it's just you're declaring a function that's delete. It has a slightly funky syntax, but it's just a function declaration.
What is its syntax?
I think it's like, if your type is type T, then it's like tilde T is the name of the function.
Okay. But so you've declared a type with type declaration. But the thing that's confusing me is this, okay? The things you're defining here are keyed to a type. Every one of these, to expression, from expression, on, free, these are all type-related things. Whereas for a given type, there could be 1,000 functions that all take these random types. But the thing you're defining here, and the thing that it is cognitively connected to, is it is the on-free declaration or the to-expression declaration for a given type.
Well, kind of. I mean, but the thing is, not really. Not in any way that's different from a function. Because first of all, this could be polymorphic. So for example, I could have one declaration here that works for several different types.
By having a type union. By having the second argument.
No, by having this be a type for all, or for all types.
Yeah, if you define like an abstract type that your concrete types all all implement, then you can have like, for all type, and then you can have a conditional that says it's an element of this abstract type.
But look, when we explain this to people, the way the explanation is going to go is you set up a type. Okay, you can define ways to free things of that type. You can define ways to serialize things of that type, and so on. That's the way you'll describe it.
No, I think that the way, if you want to know how you actually document this, realistically, the way people will encounter this is they define a type. And again, this only comes up if you do the low level way of defining types. Most of the time, this gets done automatically. But you happen to have a case where you need to define this lower level type, and then you try and return it from your function to the evaluator, and you get this message saying, basically, if you want to do that, you need to define this function here. And that's how you find out about it, is because at some point it would try and compile something that needs one of these functions, and there would be an error because it's not defined.
Stephen, if I could jump in for a sec, I think you're sort of gravitating to something like, well, why don't we put, this code in the type declaration because it's associated with the type? And I think multiple reasons. One of them is that you can make these polymorphic, and that doesn't do that. The other reason is that all the other kinds of methods that are associated with the type are implemented through a function declaration. They're not part of the type. I mean, if you think about, if you think in terms of classes, you might, it would be the same thing. Well, why aren't we putting, these functions in the type declaration because they're sort of method functions for the class? It's like, well, we could have done that, but the way our type system works and the way we've chosen to do things is more like, is not like the more C++ way. It's just say, look, you can define a function that takes this type and then it does stuff. So what they're doing here is consistent with how we do how we do other method functions for this type. These are just specific conventional ones that will be called at certain times so that you can use them for certain things. I think it's consistent with everything else that's being done here.
Okay, what do you think they should be called?
In terms of names?
That name, yeah.
Like whether it's compiler interface or compiler hook or I don't know. What's that?
It's kind of an auto-called function. It's kind of a...
I mean, callback is what they are.
Yes, well, it's a good reason to call them that.
I mean, compiler callback has that virtue that, yes, this is something that some code that the compiler generates is going to be called by the compiler that you then, that you may define to give certain behaviors. I mean, hook is also good because it's also sort of...
It could be compiled because it's not necessary. It's the compiled code, not the compiler itself. So it's not connected to the life cycle of the compiler.
Yeah, that's true. You're not affecting you're not affecting other compilation with this. You're right.
It's a runtime hook. It's a
runtime. Yeah, you're defining other code that will be called at runtime. Right. Was auto-generate. The compiler auto-generated code with these callbacks in them, and now you're providing the callbacks if you want.
All right. So this is the thing from within compiled code that it is a function within compiled code that's being called.
Honestly, I think callback is probably the most unambiguous name here.
Okay, how about just type in another name? compiler called function.
Many functions are called.
Yeah, that's what the compiler does. Is it calls functions?
I think that's confusing because you may be using some whole set of functions somebody else has written, and your function just happens to be calling that, or the compiler calls that.
Okay, so that's.
I mean, I think that callback is nice because hook, hook kind of sounds like it could mean many things.
Yeah,
like,
hook is
like
a hook is,
and and interface is also a little bit vague because there's interfaces are a thing in lots of compiled.
Okay, so compiler callback will be the name then. Compiler callback. So this is declaring.
I'm not sure.
No, I think
that's okay.
Which compiler callback?
Yeah, I would like that.
It's a callback used by the compiler, not necessarily at compile time, but
I think that's fine. I mean,
how about I don't know whether we have the word code in any of these things, but compiled code callback.
It could have that as well.
I'm not sure about that. The only place where code is used right now is in compiled code function, and I think
does what?
That's the interface from the.
It's the object that gets returned by function compile.
Just write that down for a second, because that's by function compile. Compiled code function is a function called by the outside world that goes into the compiler. This is another part of the sandwich, so to speak. This is a function that is the opposite of that. It is a function called by the compiler into the outside world.
I don't think it really has anything to do with compiled code function, and it doesn't really have symmetry with compiled code function either.
Yeah, but okay, but I mean, it's a.
I think it's called compiled code function because I'm not sure what compile returns, but I think it's just that it's trying to dodge the name of whatever compile returns. This returns a compiled function. That's why it's called a compiled code function, actually.
Okay. I think compiler callback is the least unbelievably confusing of the things we have.
Fine.
I suggest.
Okay,
now what about the names like on free?
I'm not sure. All these example names, I think, are very tentative.
Yeah, because I mean, this preposition like on free is very different from to expression.
Sure, and I think this could be something like expression serialize or expression deserialize and stuff like that might be a little bit more clear, especially because this one has a pun to expression and so on. So yeah, I mean, these names are not right, but I think these are kind of easier.
Well, serialize to expression, serialize, okay, I get it. That looks good. Okay.
All right.
So right now, those are the only three that exist of these callbacks.
Yeah, I'll have to survey things a bit because I think that so right now, none of these exist. Right now, there are functions with names like compile, backtick, on delete, overload, blah, 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 and stuff like that. So we'll need to survey which of those exist and which are actually worth having. But
I think it's the three of these is the main ones that I can think of. So
yeah, these are the three I routinely encounter.
Yeah.
Okay.
Okay. What's next?
Okay, so this is I've reordered things a little bit because otherwise there's some topics we won't get to that we should. So basically, this is about
Krista. Hang on, I'm not sure we've completely. I'm not sure I completely understand what we're talking about here, actually. So I just wonder if it's not a bit premature to go through this. Maybe. Okay.
Well, I guess we could try and do this next time or something.
I just would like another round of going through this with you, actually, maybe tomorrow.
Okay, sure. Well, let's see. I mean, I think we probably will have to have one more of these. So if we will, then that could be the thing.
Right.
So I guess the next thing is the thing that's going to eat up a lot of time, which is expressions. So basically, as discussed several times before, expressions right now, in the compiler behave very differently from they do in the top level. And so probably eventually you would probably want to have, so I think the thing to do right now is just that we'll have some type that's kind of expression-like and can get converted to and from expressions, but which is kind of like some sort of held expression or raw expression. And
this is an expression which basically nothing happens unless you call eval.
It's the same as the expr type. It's literally the same as the expr type in MC code, Stephen.
Okay, but right, which means it does nothing. I mean, the point is that that normally expressions in the wild, like, I'm going to give a physics analogy, but I won't. But I mean, expressions in the wild are continually being continually being evaled. And these are expressions which are not, they're just purely structural expressions. And they're not, eval is nowhere to be seen.
Correct.
Unless you explicitly call it.
You can call eval on them, so.
Right, so this is one of the questions. So the basic, I think that the two main questions are, how do you make these? How do you create one of these expressions? And how do you, what's the syntax for it? And how do you evaluate them? So, I mean, the way it works right now, internally in the compilers, there's some construct called, constant expression or something like that, you give it an expr and then that represents, it'll interpret that as one of these held expression things. And then if you want to evaluate it, you call some internal function called evaluate. So I guess that the question is, what would be this outer thing? And
actually, there's another function, Christopher, is where you create one of these from other expressions in the program. So the constant expression is just make an expression that is literally the argument.
Okay, so just to zoom out for what causes an expression in the wild to be evaled. The answer is it has symbols that are in the symbol table and have things associated with them. If those symbols were not in the symbol table or didn't have anything associated with them, the thing would just sit there. Right? I mean, the thing that causes the evaluator to get any traction is the fact that there are those values defined. So in principle, one could imagine something, a super block, in which all values are removed from every symbol. So all you have is just the name of the symbol, and it has no values. It has no down code. It has no down values, etc.
I just think that's not quite. If you had a symbol, an expression entirely built of strings or numbers or something, the evaluator would see it, would visit every part of it once, but it wouldn't do anything. So maybe that's a detail, but I'm just thought I'd say.
Well, unless the evaluator has side effects, I don't know what difference that makes. But the main point is that the thing that causes the evaluator to get traction is that these named symbols.
Correct. There's symbols in there with names, and they do
with names which have other associated, which have evaluation semantics for them.
Correct.
So in a sense, were we to have kind of some super block thing that simply switches off all values for expressions, switches off all things associated with symbols, then we would have, it's not clear what we could do with that at the top level.
Right, I mean, because this is the issue, is the fact that, if you had a super block, first of all, you wouldn't be able to use any functions inside of it. And second of all, you wouldn't be able to use any functions outside of it because it would be, have head super block or whatever.
Yeah.
That's different from this.
Okay, the problem is, as soon as we have an expression structure that has, that has encrustment in it, has some kind of protection against evaluation in it, it does not have the same structural form as the expression, as the inert expression that you're referring to.
Right. I mean, I would argue, that, based on also, the previous discussions about this, I would argue that basically the full sort of, MC code expr struct that's available, in the compiler, there will not be a syntax that lets you fully emulate that in the top level. And so I think that we're probably going to want to have some expert type in the compiler that's sort of more interoperable with the top level expressions, or has behavior that's more similar. But I think if we want to have this, basically the MC code expert, then I don't think that the interface for creating it, manipulating, et cetera, will be compatible with the top level.
Okay, so one possibility is it's like a thing that's been created in a vacuum and then it's pulled out and put in the air and it suddenly oxidizes. I mean, in a sense, what you're describing is you could imagine something that is cooked in the compiled code level as a pure expert struct. And as soon as it's taken out, it's exposed to the air, it's oxidized, it's evaluated. That's one possible model.
Sure, yeah.
And the prevention of oxidation is a difficult matter. I mean, you
in the top level, it's difficult, right? I mean, I guess the real issue is just the fact that it's sort of very useful that in the compiler you can do things like call head on one of these expressions, and you'll get the head of the expression. You won't get hold or inactivate or.
I know. So I mean, basically, what you're saying is, when the thing comes out into the air, so to speak, just like toExpression has a third argument which says how should it come out, because that's another case where toExpression is a direct analog of this, I claim, of the expression once it comes out of the parser is unoxidated, so to speak, unoxidized. And then what's going to happen to it? And toExpression has that third argument that says what to do with it to either protect it or not as it comes out of its pristine state.
Okay.
Do you agree with that claim that it's similar to toExpression? What has to happen? toExpression is making a pristine.
I guess so. I mean, when it gets returned to the top level, but there's also the issue of evaluating it in the middle of compiled code. I mean, if you make it.
That's a different thing. So right, but I mean, once you're doing that, the evaluator is going to just have at it every part of that expression. It's not going to, nothing's going to be held. It's just going to be like, it's just the same thing as if it was returned like from toExpression without a third argument.
Yes.
Okay. Well, I think that that's not an unreasonable approach. That is that in the compiler, you're peeking and poking at this expression, just like you could peek and poke at a string before you feed it to toExpression. You can do anything you want to a string. It's never going to, nothing's going to blow up. It's just that here, okay, so the intermediate case would be manipulating an AST in the top level. So my claim would be that perhaps we should provide something, well, like we can manipulate boxes, but maybe in addition to a string boxes, we should provide an AST for expressions that you can manipulate in an inert way.
The only difference is the fact that if you called head on that AST, it would not return the head of the, it would
not if you called ordinary head. No, that's correct.
It
would not return an ordinary head. It would return. It would, yes. I mean, I think
the point is the AST. It would return an AST adorned head. Yeah. I mean, there's an AST. It has a notion of a head. It would return the AST-ified head.
Yes, which might be wrapped in. I mean, look, but I think the way to think about this perhaps is, within the compiler, the thing's operating in a vacuum. There's no air. It doesn't. No oxidation happens. As soon as well, you can either explicitly puff air at it with the compiler, or you can return it like the parsed expression of toExpression. And as you return it, whatever is the returning mechanism should, like toExpression, allow some kind of wrapping at that point. And then the missing functionality would be that an alternative thing that you could do is to go from the compiler expression struct to a top level AST, which you could then manipulate more conveniently than you can manipulate a string, but less conveniently, but admitting that it is not the same thing as a plain expression. I mean, in other words, we've been dancing around the possibility that we could have a plain expression that would not mean anything, where plus has been switched off. I think we've danced around that enough to have decided it's just not going to work. and that you can micro adorn it with inactive, you can wrap it with hold, or you can fully you could fully wrap it with an activate, or alternatively, you could have some AST type mechanism that has all kinds of metadata tagging. And we need good interoperability between the hold representation, the inactive representation, and the AST representation. And
all
then
this you're talking about is at the top level, right?
Top level, yes.
All the evaluator. Yeah.
Right. And I'm saying that then what should happen is in the internal code, it is yet a different representation, which is the unoxidated, raw expression, and that these different forms, like the AST form or the held form and so on, should be easily gettable from that as it comes out of the compiler. And things going into the compiler, you should be easily able to construct this naked expression form from an AST or something like that.
Right. So I think the way to do that, though, I mean, I think that's a slightly different question, because I think the way you would do that is just before you return it, you cast this raw expression or whatever it's called to a expression AST or something like that, and then you return their expression AST. That depends on its idiomatic way of doing it.
Right. That depends on its compiler callback
No, I would argue that the expression AST data type, of course, that has its own compiler callback definition for how it gets serialized to an expression and so on. I would argue if you have a function that fundamentally returns a raw expression and you'd like to return this to the top level as a AST, then the way you would do that is not by redefining the way that raw expressions get returned everywhere. You would just call cast on this particular raw expression, convert it to an AST, and then that would have its own callback code.
Wait a second. So what you're saying is, for the compiler, within the compiler, there is an expression data type, which is which has nothing to do with the evaluator. It's merely structural.
Right, which is why I think it should have a slightly different name. But yes, there's something with it. Expression like.
Expression. Huh, no. Expression structure. I'm not sure there's anything wrong with calling it expression. I mean, every other type. Okay. Look, the thing is, integer 64 doesn't come with any risk of evaluation. There is no risk of evaluation for integer 64 because it's a no-op in the evaluator. Okay, is there a symbol? Is there a data type symbol in the compiler?
No.
Not at the moment.
But there could be. So let's think about what that one would be if we had it. Because that's going to have the same issue as expression.
Yes. See, this is why I like a name like raw or something, because you could have raw symbol, raw expression. Because here's the concern, right? Right now, this is how expressions work. Right now, if you write something like, the point is that we could, I think we want to do this in a way so that in the future we could add something that is more like the top level expression. Like for example, based on the way that the compiler works right now, you can't just write 2 + x and have that be interpreted as an expression as you would in top level, right? Instead, there's going to need to be some wrapper that's another thing that we need to name. That's like this is an expression literal. If you get what I'm saying. In the same way, you need quotes around a string, right?
What the heck is an expression literal? In what? Oh, you mean? No, I don't understand. You mean?
It's making a constant.
So what I'm saying is that, like, for example, suppose I wanted to do something like, say, f is an expression, and I have another expression that's like 2 + x. And I'd like to, I have expr, right? I have something like expr1 = f, expr2 = 2 + x, and then I want to say expr1 of expr2, right? I mean, that's something I can do in the top level, and I'm going to get f of 2 + x, right? So the point is, in the compiler, if you write 2 + x, if I write, expr2 = 2 + x, it's going to complain and say, I don't know what X is. I don't know how to, I can't do plus on this thing. I don't know what it is, and so on.
I get it.
Okay. So the point is that the way that I think we do this right now, which is nice because it means that in the future we can do, it's compatible with the fact that this is a different kind of expression than we have in the top level.
Okay,
there's going to be some wrapper around here that's, some,
raw
magic
expression.
compiler expression of this. And then you're going to, this is going to create this magic compiler expression object that you're then going to manipulate in all these ways and so on.
So in other words, you are leveraging the parser, but that is otherwise, is that function going to be hold all?
Well, it's usually
this is in compiled
code. A function, Stephen. So it's held anyway. It's in code, so it's held anyway. So
right. The big question from before was, should we have a version of this that has a top level equivalent? And I think the answer that we basically come to is that we cannot make a version of this with the top level equivalent. It just doesn't work.
Yes.
And so. Right. And so I guess the question is sort of what should this, one of the questions here is.
But one thing that should be the case is that if you take a piece of compilable code, the thing that you gave as the, in function compile, you take that function with a typed, essentially the typed lambda, and you simply run it through the top level evaluator, it should just work.
Well, we talked about this in the one 2 weeks ago. Most things will just work, but there are some things that really like this, for instance, that at least without a lot more work, basically can't just work. Just because of the way that, or like another example is if you call a function from C, like the stuff with library function declaration, if you define a function that's going to call malloc, right? That really can't just work from the evaluator. It's just not how the evaluator works.
If it's going to have a call into C code, if your pure function has a call into C code, you claim you can't make that work because it's too interwoven with the things that are.
If I call a function basically yes. Like if in the middle of my compiled code I use some low level thing to allocate memory on the stack. This cannot possibly work. Can't
possibly work in top.
Doesn't mean anything, right?
Okay.
So I think that in ideally in basic I think that the goal should be that as much stuff in the compiler we should make it so as much stuff in the compiler is compatible with the evaluator as possible. I think that anything that can be written in some way in the evaluator should be written in the same way in the compiler. So there shouldn't ever be, two competing ways, but inevitably there are going to be some things that you can only do in the compiler, because that's part of why the compiler is useful.
Right. Okay. But so this is, okay. I'm still coming back to this object here because I can imagine wanting to do a toString. This is like another thing that toString might, that 2 plus X could be from a string, it came out of a parser. For example, I could imagine a quite useful case where that was created by a template, string template, expression template, or an expression template. Think about the expression template case, because that's a case where the thing is a structurally created expression that didn't hit the evaluator yet. How does that work? I've forgotten how that works.
Hold on. Template expressions, when you call template apply, it'll evaluate the template expression. It fills it in and then it evaluates it.
Right. But what I'm saying is you can imagine a template expression where it doesn't evaluate it, where it merely structurally creates it, that would be a useful thing to do. For example, in the compiler, right? So my question would be, if you look at that, we've got these different cases. We've got toExpression, we've got template apply. What else do we have that, in a sense, structurally creates an expression without the immediate need for evaluation? If you understand what I'm saying.
Yeah, I'm thinking.
What other constructors do we have?
Well, we have deserializers like reading an MX file or reading from MathLink. That's not evaluating.
Right, or importing.
Right. Could you write some of these down just so we know what all of these are? So we've got two.
Okay.
We've got two expressions.
I'm not sure what these are. Functions that produce
structural
expressions. I mean, they produce expressions, and there's a question of whether you'd like them to be evaluated or not. That's kind of the question.
Right. So it's two expression, template apply, import. What other kinds of things? From a byte array.
I'm not totally sure where you're going with this, though, because I think it's sort of.
Well, what I'm claiming is
I think the most common place you're going to get these is not from calling to expression on a string. The most common place you're going to get this is that you're going to write a literal, like, in your code, probably.
Okay, so write that down as another case. So another case is from the parser, automatically from the parser.
Right. And the point is, like, for example, in the parser, well, yeah, I mean, in the parser, the way you specify.
It's not necessarily from the parser, because you might inject it into a function with, using with or something. It might have been created programmatically and then injected.
Well, no, look, the other case of this is you made it structurally inside the protection of a hold, and then you want to inject it without its hold. You constructed it, with its, like a, I don't know, like
sure. That's a case that's, by the way, very annoying to do right now.
Could you write that case down?
That's annoying independently of the compiler. That's incredibly annoying.
Right. So the general category here is meta programming and structural creation of expressions independent of their evaluation. Right. And one version of that is you stored a giant expression in a file, in WXF, in text, whatever. You want to bring it in as a raw expression. You do not want evaluation to happen. This was kind of what we, when we were talking about the WDF format, data format, one of the things that was an issue there is we don't want things to blow up on arrival. Right, that was a specific goal, because if you think you have a data file and oops, it's like the famous macros in a spreadsheet type thing. You thought you had a spreadsheet, but actually it has macros that sing and dance in all kinds of ways, which you don't want. So
sure. I think the issue, though, I mean, in all these cases, the big question is it's just sort of a syntax question of, when I create this object, I need to have some argument that's sort of the thing that gets wrapped around the object before I return it to you, right? And basically, and the only reason we have that is because we have several different ways of stopping evaluation, right? If we had one way of stopping evaluation, you might just have a Boolean that's like, should you
no, because as soon as you have the expression explicitly given, it will be oxidized.
Right. But I mean, the point is that the way that, I mean, I argue that the situation with this is pretty different from the top level, because again, where do these expressions come from? I think they're either going to come from, it's an input to your function, which comes from the evaluator eventually, but like it's an input to your function, or it's something that you've typed in as like a literal in the middle of your code.
Yeah, exactly.
That's from the hold of XYZ.
Yeah, that's right. From the parser case. Look, another case that I'd like to point out is that I could imagine code. Look, let's say I've got an example. Okay, let's say you are writing compiled code to deal with different Boolean functions. You've got a whole giant collection of you want to make optimized code for 1,000 different Boolean functions. So you write a template, an expression template that has a slot for a Boolean function in it, and you want to run the compiler for each of those things separately. Then that's a case where you are injecting. I don't know whether that case is particularly interesting, but I mean, in that case, yeah, I mean, well, maybe that case doesn't really matter, because you could have evaluated the Boolean function in the evaluator first, although I can imagine you might not want that. I mean, you might have not P, and you don't want law of excluded middle, and you want that to be entered literally, even though we probably automatically simplify that. I'm just saying there are cases where you might want to inject something okay, no, I lost my train of thought there. I mean, the point is you've got compilable code, but there is a slot in the middle of your compilable function that you want to get from the outside world. Is that reasonable?
Right. So the way that you normally do that is just by having an argument to your function.
I know, but not if it wants to happen at compile time. I'm saying you want to separately compile functions for each of those Boolean expressions.
So I'm not actually sure. I mean, maybe this is a question for Tom. I mean, when you use constant expression, native backtick constant expression right now, if in the expr you write, you write, $system ID or something like that, will that get evaluated at compile time?
Surely, yes.
No, it's held. If it's in a function, it's held.
No. Oh, I'm
sorry. You're right. Yes, because you'll write your magic compiler expression. You'll write $system ID or $system, right? And then this is just represents the expression $system, and then this will only be evaluated when you take this expr2 and either return it to the evaluator or when you call eval.
You want a way of working with $system.
Right. So can I just understand?
Execute the code on different platforms, for example.
Yeah. Can I understand? If this thing was in the middle of an expression template, would it work? I think the answer is yes.
Do you mean in compiled code or in the evaluator?
No, I mean in the evaluator. The evaluator is dealing with the template apply, but it's inserting the, it's putting the insertions
this
into
construct.
This
construct, I think, doesn't really make any sense in the evaluator. Like we've already been saying.
I understand that. I understand it. But just write out an example. Function compile of something with a template apply.
Is the template apply in the function compile or outside?
No, it's outside the function compile. It is operating on the function compile.
Okay, then this would work because when you call function
think it would
compile,
work too. Yes.
Function is hold all complete. So
yes,
I
think it will just work. I think it will work because template apply is a purely structural operation.
Yeah.
I don't remember how do you indicate a slot there? Template slot, right? Okay, fine. So you can apply that whole thing to something, and it will go into the template slot. Okay.
What? Get rid of function compile and function compile adding anything.
Yes, you did. That's the whole point. That's the whole point.
It doesn't. Yeah, I mean, right. That's
the case where this is meaningful.
Right. It doesn't really matter if the function compile is inside or outside of the template apply. It's the point, but it doesn't matter either way.
Right, but you want to do this for function, declarations as well as within function compile directly.
Sure. Yeah. I mean,
so the function is important. Yeah.
Okay. All right. So then
something
okay.
Like that.
So just to understand the models here. So within compiled code, would you ever want at runtime? Okay, runtime to expression, there's presumably some way to go from a string to one of your magic compiler expressions. How would you do that? So let's say I'm writing code.
Right.
I see that.
Right now, if toExpression works, I think toExpression does work, and I think it just by default goes to one of these, which is incompatible with how the evaluator works. Probably it should have some third argument or something. It's like you'd write toExpression of, something.
The obvious thing to do would be to have its third argument by default be an automatic that depends on its evaluation environment.
The issue. The reason I say I think it should be like this is because if you do it the other way, then the problem is that we can never, if we end up adding an expression, which I'm not sure if we will, but I mean, if we end up adding an expression that's more compatible with the top level expression, then now toExpression does the wrong thing, right? It returns the niche, I'm doing low level expression manipulation object instead of the less niche one.
Okay, so I mean, yeah, I understand that. But I mean, so in the code, you will be writing, so okay, so this wrapper should be able to take, for convenient metaprogramming, this wrapper should have an easy way to go either from a raw typed expression like 2 plus x, or from quotes 2 plus x, or from 2 plus x's boxes, or from 2 plus x as an AST. All of those should be easy for this raw expression wrapper to process into something which in the compiled code will be represented as a raw expression. Do you agree?
Sure. Yes, although by far the most common cases I think will be from the parser and as inputs to the function. But
yeah, so as inputs to the function, as in a symbolic input to the function that is simply passed through directly.
Yeah, typed input to the function. Yeah. As
Well,
in,
by
as
typed,
in
we
I'm
mean
calling
with a
function
keyboard.
compile of function of, you know, typed e comma raw expression or whatever it's called, comma, you know, head of e. Who knows what I'm doing? But right. I mean, I think this is probably the most common way of getting expression. But like, suppose I wanted to apply f to this expression here, right? So here's like an example of a very, you know, simplified but typical thing you'd like to do. I have an expression as an input. I'd like to apply f to the expression and evaluate the result. So the question is how to do that. So the first kind of, you know, right? I think probably the zeroth way you do that is you'd have your, again, you need a name for this, but you'd have your, you know, magical compiler expression of f of e, or actually maybe I should say the absolute zeroth way to do this because this doesn't currently work. The absolute zeroth way to do this is this, but this should also work.
Wait a minute, what is that now again? Okay, so the of f, yes, I get it.
Right. So this is already a raw expression. This is, well, I'm being inconsistent with my names here. This is creating a raw expression from this literal here, and then it's constructing. Yeah. And then how do I evaluate this? This is what you'd like to write, except for the fact it's a horrible pun because evaluate does something completely different.
Okay, so we need another function here. We need a family of things. We need one that represents an expression purely structurally. We need one that basically takes a purely structural expression and evaluates. Right?
Right. And critically, it evaluates it. And unlike release hold takes a held thing and returns an unheld thing. This is going to evaluate it and return another structural expression. It's not going to return a normal expression, if you get what I mean.
Yeah, I understand what you mean. So could you just write down? So we need what we might call, let's just call them for now, structural expression and structural evaluate.
I think the structural word is not great.
It's not great. It's not great. We're not. But I just want to understand what else we need. So then, for example, to expression could have a third argument of structural expression. Oh, but there's a different. Wait a minute. There's a different thing we need. We need the encruster for the top level. No,
what do you mean?
Wait a minute. No, wait.
Actually, I guess maybe one last word we need is we need the name of the type.
Yes, we do.
But I think that'll fall out of this.
Okay, but hold on. We need a different thing. We need the thing. Structural expression is what you put in inside compilable code to represent. If you just type structural, okay, it's more complicated than this. We need structural expression. Look, listen, there are different things it can take. Okay, so structural expression has to be able to go from string. It has to be able to go from parsable expression to an internally represented structural expression. It has to go, something like it has to go from a string. You know, like could you just write down?
I understand what you mean. This case, you can't
We can't
you can't do this because this is itself
an expression.
Right, so it has to be
an expression.
Look, just write down in your thing above it structural expression. Just say string to structural expression. Just another function called string to structural expression.
I would argue that this should just be to expression, but yeah.
Perhaps so, but let's just write these down, okay? And then we've got, okay, then I claim there's another function that is needed, which is the encruster, by which I mean the thing that takes an object that can be at top level that wraps around a structural expression, wraps around a thing, okay. Within compilable code, when you see structural expression of 2 plus x, that is a signal to the compiler that 2 plus x should be created as a structural expression and then just inserted there, okay?
Yes.
But let's say you extract that whole object and it has somehow managed to arrive at top level as a purely structural expression. You need an encruster to keep the evaluator from putting its fingers in.
Okay. Well, okay. Yeah, I guess maybe. So
and I claim
okay.
That's a different function from structural expression.
Well, okay, no. So here's the, I'm not sure how that would manifest itself as a function, right? I guess the part of the question is, let's say I have this raw expression type or structural expression or whatever you want to call it. I return it to the top level as this code would do. Imagine I don't have the evaluate around it, right? Mm-hmm. The question is, when it comes to the top level, should it just be an expression and then be evaluated and so on? Or should it have some wrapper around it? I think it is more useful if it's just an expression.
I agree. By default, I agree with you.
Okay.
But then the return, just
okay,
like...
so you want to have a function that you apply to it that basically is like,
if I'm returned,
like, by the way, level, when you get returned, have this weird thing around you. I would argue, though, that there are two. I think that that's not necessary because there are many ways of getting around it. One way of getting around it is if we had some AST type, you would just cast this object to an AST type, and then that would get returned as some AST. So you'd write something like this: cast of blah, comma, AST expression or whatever.
But hold on. One of the reasons we're having this difficulty is that in our function, in our type lambda, we're not defining explicitly the return type. I mean, that's what you're effectively doing with the
sometimes you do, but you don't always have to.
Right, but the cost is effectively declaring that. Is there any other way to declare it?
Well, there are cases where you can declare, yes, in function declarations, and actually in this case here too, you can put the type around the outside of the function and you can give it a return type. But if the return type doesn't match the type in here, like if you tell it you're returning an expression AST and the internal code is actually returning a structural expression, it's going to say there's a type error. It will not implicitly cast it. You have to do it yourself, which I think is the right thing because it's more similar to the right top level anyway. Totally. But now another thing you could do though is also if we had a function, for example, if we had some expression AST structure in the top level, we'd presumably have a function for constructing it from an expression. Like, okay, imagine that we want to turn this as a tree expression or something, that wouldn't be a type actually. But, the point is that we could just apply that function to this thing. You could just say tree expression of this maybe.
Exactly.
Right. And that will return a tree. Or for example, we probably want to have a definition of hold that takes a raw expression and returns a raw expression with hold wrapped around it. So you could just do this and it would return a held expression.
Hold on, hang on though, Christopher. Well, in that case, but you've got to think about the sort of binding of like, say, local variables in that. So does hold really have different?
Okay, sure. Like if you had
you really do have to think about that. Sorry.
Look, the question is really this: whether in the compiled code you can just say hold there to get, whether you can put the encruster into the compiled code or whether you have to have it as a meta thing, specifying.
I'm not sure what you mean by encruster. I mean, other than writing something like hold or tree expression.
Yeah, I'm saying, right, that's what I mean by the encruster. I mean that you would have a thing which in the innards of the compiler is a purely structural expression. It is then released to the air. It's about to oxidize, right? And the question is, don't let it oxidize. put a wrapper around it, but so that as the thing is released to the air, the thing has something automatically wrapped around it before it ever gets out. And that's what I'm describing as the encruster. And my question is, do you put the encruster on when it's still in the oven or whatever, in the vacuum or wherever it is?
I would argue yes. You should put it on while in the compiler, because it's just very easy to do that. As opposed to having some weird option to function compile that specifies how expressions are wrapped before they're returned or something.
So, next question. Structural expression. This thing that normally you simply type 2 plus x into it.
Yes.
But is it possible, like with the template apply, maybe the insertion function, I'm just a little bit unclear. You want to be able to just give it a string. You want to be able to give it an AST.
I'm not sure you want to be able to give it a string, because again, I think there's two expression can do that just as well.
It already does, yeah.
Can do what? Can go from to expression, can go to structural expression.
Can take a string and turn it into a structural expression.
Okay, yes. At the top level, when exposed to the evaluator, what does structural expression of 2 plus x do?
If you just write that in the top level, I think it gives you a message.
But what does it return? Does it just
Probably
stay
2
unevaluated?
plus x, or just unevaluated, how about? I think that's probably the best. It's unevaluated, and maybe for safety, it's hold all.
Well,
I think that makes sense.
You've got to be careful about making things hold all.
I think that case is reasonably secure, because that case is actually a meaningless piece of gunk at top level.
Right, and I'm just saying it doesn't have to be hold all, but it could be hold all, just because if you ever have something, right, if one of these is released to the top level, when you wrote it in the compiler, you probably didn't intend for it to be evaluated, or like to be safe. You don't want it to.
All right. I'm convinced that string to structural expression is irrelevant. Okay, so I'm saying now things like import should then have a structural expression, element.
Perhaps, yeah. I think that would be good. Right now, import there's no versions of import that works in the compiler, but they could.
For some reason, I never remember how to do this, because I always use import for WXF files. There's a what the heck is the name of just pull in a WXF file?
The byte array one, or
no. I'm just saying I write out WXF files and I read them in. But don't we have a function that specifically does WXF files? I just use import and export.
Do you mean MX for dump, save, and get? I'm not sure if there's one for WXF.
I thought there was one.
Try and binary serialize.
Yeah, that's right. I'd forgotten that function. I assume it's equivalent to export to WXF. Oh, as a byte array. Okay, that's why I was, Good.
Okay.
Okay. I see, that just returns a byte array object. That's why I don't use it, because I'm trying to put it into a file.
And that's probably just false, because who knows, some randomness in the sampling or something.
Yes. Okay. So, all right. So then, okay, let's talk about structural evaluate for a second. That's a thing that's inside the compiler. Structural evaluate. What would that do at top level? Nothing.
Maybe, just maybe, the structural evaluate could take one of these structural expression objects, evaluate its contents, and then return another structural expression object. But
yes, okay. So let's do the following argument. Why is it not the case that structural expression at the top level gives no message? It's just inert. It's just like hold all complete. And
I guess it could be. And the only discrepancy between that and the compiler is that in the compiler, there are lots of functions like head and reverse that are defined on it, and that don't just do what they normally do with expressions. They go like one level deeper, but in the top level, they won't go one level deeper.
Or just do nothing. And then structural evaluate for the structural expression could sort of, could just do the obvious thing and return a structural expression. I mean, that would be quite useful, I think. It's the thing where, because you can imagine building a structural expression. Well, how would you build it?
Well, maybe. I mean, well, to be analogous, and again, I'm not sure we want to okay. I'm concerned about trying to sort of carry this over to the evaluator fully, because I predict that, as we already know that constructing one of these in the evaluator is pretty fraught. And so if we just sort of haphazardly,
fair enough. And what up values work.
But the consistent thing would be something like structural expression of f of, this is how you'd construct them, as you'd say, this comma this would turn into structural expression of f of x comma y.
God.
And stuff like that. I mean,
I don't think we should do that. I just don't think we should do that. I think that's way too horrifying.
I think the basic thing is, I think making a top level version of this that's sort of similar to the compiler version might be useful, but also involves like a vastly higher amount of work.
And also,
it might be a bad idea.
Yeah, because I mean, then we've got a third mechanism beyond hold and inactive, a third mechanism for unevaluated expressions.
Yes.
I don't think it's a good idea. I think it's enough to just say structural expression is a creature of the compiler. If you return one to top level, it's just a pile of gunk.
Yes.
And if you want something different done to it, then say first of it or something.
Yep, I think that's good.
Okay. So then structural evaluate, at least initially, would do essentially nothing. Okay, now let's talk about the names.
Yeah, that's the big question, is the names, I think.
Okay, so let's talk about the name of structural evaluate.
What's the name of the type? That's not unuseful.
Okay.
Because they should be somewhat consistent.
Right.
Why not structural expression? Quote structural expression.
I still think that the word structural is kind of
it's all
meaningless.
It is meaningless, but the whole point is that this is intended to be meaningless.
I think
the point of this
raw is better.
Raw is better for the type, but I'm not sure raw works with raw evaluate, right? Or evaluate raw. Like, I feel like those sound like they do something different.
Well, raw evaluate, if you're applying it to a thing of type raw expression, that makes sense.
That makes sense. But if you just see the term raw evaluate, I mean, I guess it's a little like this already, that when you see the function name evaluate, everyone has the function called evaluate does not do at all what you'd expect it would based on its name. But
I know, I was very proud of the fact that in SMP, the function SMP was the eval function.
I see. Well,
but that was never as much of a success as I thought it would be.
And part of the problem is that, I mean, maybe SMP was different enough, but there's no eval function in Mathematica because, it's just identity.
No, I know. So was it in SMP. I mean, it was SMP. The SMP function had some extra control things in it, which were also a bad idea. But that's a different story. I mean, we will be back to having that in due course as we think about multi-threading and all those kinds of things. But in any case, so write down. Okay, so what are the candidates for it? So we got raw expression as a type. I'm still pushing structural expression. The reason I'm pushing it is that it is an expression in structure only. It says length of blah, 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 blah. The structure is meaningful. There is no semantics. It's purely syntactic. It's an expression in structure only. It has no, it has been devoid of semantics. I also worried about raw because somehow raw, I don't know.
I mean, raw is a bit vague, but I think structural is also, I mean, these names are taken, but just as easily it could be hold or held, let's say, and held expression, held struct, held evaluate.
Could be, but I think that's
no. I mean that one it can't.
That's going from a different way. I mean that's saying what you don't do to it, whereas structural is saying what it is. It is representing the structure, but it is nothing beyond representing the structure. So it's a glass half full type thing. What other candidate names are there?
Well, maybe on that note, you could call it like an expression scaffold or something.
Yeah, actually, Dan on our live stream suggested expression skeleton. But it isn't really a skeleton because the whole thing, the whole thing is there. It's not just I mean, that's why I'm saying structural expression is.
So skeleton evaluate is too bizarre.
Yeah, that's too bizarre. It might go with anatomy plot 3D.
Right.
Skeleton evaluate is after you specify the joint positions, skeleton evaluate will put it in those positions for anatomy plot 3D.
Static expression?
Interesting.
That's not crazy. That's interesting.
Static evaluate is a little bit of an oxymoron, but
yeah, but you can evaluate static because then that you're applying the evaluation to the static.
Yeah, that's true.
I don't know. I think will be hard for people to understand, particularly when we have a whole world of dynamic. Particularly when we have a function called dynamic, which has absolutely profoundly nothing to do with this.
Yeah.
All right. So what else? I mean, the thing that I keep on coming back to is this represents the expression. It has its structure is correct. It just doesn't mean anything. It's been
inert.
Meaningless expression.
Actually, I like inert.
I mean, it's not meaningless. It's inert. It doesn't do anything. It just sits there.
Inert is a possibility, but how does that relate to inactive? And why do we have any names? Do we have any
what
names that use the word inert? Just look.
We'll look very far.
Okay, fine.
I think we're okay.
Inert expression is not terrible. So then what would it be? Inert evaluate?
Yeah, hold on, let me.
So then the type would be quotes inert expression, and the head would be inert expression. Evaluate inert actually is a little better than inert. Well, I don't know. Inert evaluate might be better because of the weird character of the function evaluate itself.
Yeah. Those aren't bad.
Yeah, evaluate inert sounds like it's trying to associate itself with evaluate, which it shouldn't.
Right. Inert evaluate sounds more sensible.
Could we avoid the evaluate by having cast inert expression to expression be documented as evaluating?
Yes, but that's an incredibly
well. I mean, I thought about this, but then the issue is that we can only do that if we have this expression, this evaluating expression type, which we don't have right now. And
okay,
yeah, I mean, that's the real problem, I think.
Okay, so by the way, if you have inert expression, you can also have evaluating expression or evaluatable.
Which would arguably be just the thing that we'd call expression. Probably, maybe.
I think it would be clearer to call it evaluating expression or evaluable expression, evaluating or
We don't know how useful it's going to be, Christopher. We haven't really experimented with it.
I know. I mean, right now, there's really nothing. There's nothing in the compiler right now that really would really benefit from this. But at the same time, it's sort of like, for example, if we want to do algebra, for instance, if we want to do symbolic algebra, it's like you kind of need to have, where there's lots of symbolic expressions running around and evaluating and stuff like that. Like you kind of need to have something like that.
So let me ask a question. If you return an inert expression from the types generated inside the compiled function give you an inert expression. It's now returned to top level. What happens?
Disappear.
It evaluates.
It just evaluates. Okay, so
it's a regular expression.
It's been somebody with more Tom, a chemistry analogy here. You take the thing out of the oven, it's in a vacuum, and then I have the right analogy, right? And then the thing starts to oxidize when you put it in the air. That's true.
Yeah.
What?
Yeah. That's
okay. But I want another analogy for this, because like as soon as you take it out of where it's being created, it immediately,
the wave function collapses when you observe it.
That's way more obscure.
You're putting the salt in the soup or something.
I'm totally confused. I'm just saying that there's a thing which, during its construction in a vacuum, for example, has some structure, but as soon as it is out in the wild, it is always being coated with it's always having something. And that's the way
it's like
I
you're
evaluate
constructing it at absolute zero or something, and then you heat it up to room temperature, and then it suddenly starts going crazy.
Or you get things that are light sensitive. I mean,
yes, that's a good example, right? Film,
comes up,
right? Good idea. Yes, okay. So this is like photographic film. It's in the dark room, and then it's although
that's called activate. That's reacting. Well,
yes. Anyway, my point here is that you're imagining that there is nothing to stop it. As soon as that function returns, there is the only way to encrust it upon return is to have encrusted it in the compiled code by, for example, saying hold.
Correct.
Yes. Right?
Or by converting it to some other type that has different, remember we talked about the, compiler callback.
Right, like if you converted it to a tree object.
Wait. On the compiler callback, are you saying that the two expression method of the compiler callback? Okay, let's say I'm going to return a struct of some type. Okay.
Yes.
And then you're saying that callback is the thing that gets called when the thing is about to return itself to top level. Is that correct?
Yes.
Correct.
Okay, so its name to expression is rather a terrible name, particularly given what we're.
Yeah, it's more about serialization.
Well,
I think
I wouldn't call it serialization. I would call it's being returned to top level.
It's not quite. It's not quite, because you could invoke it inside the compiler as well. Convert you.
Generally speaking, I think
okay, my claim would be, insofar as the other thing is called on free, this should be called on return.
Okay, two points. So the first point is that here's an example where it's not on return. There's a thing called kernel function, which is, if I say kernel function of, foo, so here's how you do it. Here's how you use kernel function. You say kernel function of foo, you tell it the type. This takes an integer 64 and an expression, right? And it returns an expression, for example. Okay.
Wait a minute. When you say expression, what do you mean there? Do you mean inert expression?
I mean inert expression. Let's say I mean inert expression. Okay. So this is all an existing documented top level thing. Okay. And the way you use this is that here I have my function, and now I apply it to some arguments, right?
Yep.
Well, we should probably put the type into the kernel function. It seems a bit niche.
Okay. Well, right now this is the syntax for it, right?
Correct.
I think. So in any case, okay. How does it convert this 6 into an expression in order to feed it to this function? Answer: it calls that callback above.
Exactly.
So calling this a return on return, I think, would be very bizarre. I think something with serialize is better, but
yeah.
Well, no, but hold on, it's not serializing. By the way, you've got a bunch of weird background noise. It's not serializing. It's turning it into an inert expression, isn't it?
But that's, well, kind of. That is what serializing is, isn't it? It's taking.
No, serializing would also be putting it out as a byte array into a file.
Oh, that's serializing to a byte array.
Serializing. I would say serializing is just about writing it into some format from which it can be, some kind of inert format from which it can be deserialized without losing data. That's what I would call a serialization.
Okay, fair enough. But you've always got to define, in that notion of serialization, you've got to define its target.
Right. So it's going to serialize to an expression, right?
Right. But then, so in other words, the name would be something like serialized to expression. Like just as you have on free, it would be. So we should write that down.
Fine. I'll do that up here. And then the other direction is deserialized from expression or something.
I would assume so. Serialized to expression.
The question is, can we get rid of the prepositions or whatever? But
well, expression serialized would be the obvious deprepositioned form.
And expression deserialize. It's a little bit.
Yeah, the only thing with that, is it obvious which way round it's going?
No,
I don't think it is obvious. No. I think that's why
the to and from.
Yeah, okay, fine.
To and from are useful.
There's a reason that English has those prepositions.
Okay, so serialize. Okay, so what we're saying here is, you scroll down, right? So we're saying that would have a serialized to deserialize. No, a serialized to expression.
It's got both.
On return.
It's got to serialize this. It has to serialize the 6 to an expression, feed it to the foo, evaluate it, etc. The result is another expression, and then it has to deserialize that. Let's say instead of returning inert expression, it returns another
real 64.
Integer 64. Real 64. Sure.
But it's got to deserialize it internally inside the kernel function.
Well, that's in the compiler code that interfaces that is kernel function.
That will deserialize to make it into
This is very simple. This is converting the inputs to expression, calling the evaluator, and then converting it out. This is what it does.
Yeah.
You could write it in, it's not vast, not like many lines of code.
Right. Okay. All right. What else? Yeah. Go ahead,
Christopher.
We're going to go on to the next thing.
Yeah, I think we're in good shape here.
Yeah, okay, fine, good.
I think we've got some resolution here.
Okay, so the next thing. All right, sure. So this is maybe another issue. So, yeah. Okay. So basically, this is the question of how you. This is kind of. I argue this is a pure naming question. So this is, given you've defined some, say, a product type, now you want to create an instance of it, right? There needs to be some low-level function for creating an instance of this product type.
But I'm sorry, when you call it a product type, okay, every single time I refer to it, I call it a struct. Why don't we just call it a struct?
We could.
I literally, or at least have that be an alternate name. Because every single time you say product, I have to think, what the heck does that mean? Now, maybe that's
one form for this, but it could be struct.
I did at one point. I did a little survey where I looked through, like Rosetta code or whatever, and I did not find a single every language that had a keyword called it struct. There were other languages that didn't have keywords, that algebraic data types, and they might, in their documentation, call it a record type or something like that. But everyone that had a keyword called it struct.
We should just call it struct, because that's what everybody at this level of programming knows it as a struct. I think.
I think struct and union go together better than product, and I think product and sum. I know we.
Yeah, struct and union will be the things.
Yes.
Yeah, I mean, I think I maintain union and product are actually not at all incompatible because it's the Cartesian product and it's the set union.
Yeah, but that's what I mean. I said it should be called a direct product or Cartesian. I think just product by itself is confusing. I've said that before.
Okay, so I think right at that point, I think you're probably right. But at the same time, having a type declaration of Cartesian product would also be a little bit.
Oh no, I know that's exactly. Right. So I think struct is great. I love struct.
Okay.
Okay, fine. So struct. So you've defined a struct, and you'd like to create an instance of it.
Yep.
So the question is, how do you do that?
You create an instance of it in compiled code.
In compiled code. So this is a little bit like calling create data structure, but this is lower level in a couple of ways.
But that would be like a new, what often will be called new in some systems which have to do explicit allocation. Is that right?
Yes, basically. I mean, like for example, in C++, it's called new.
Is it always a struct, or could it be all kinds of?
It's not always a struct. So there's the two that we have right now are structs and unions.
How about can I suggest we call it new instance or create instance? Or is that crazy? No, that's crazy. We've got things like find instance and things. Create compiled instance. I mean, why is it a compiled object? It's not really an object.
I'm not sure it's a compiled object. That's one of the questions is naming. I mean, that's really the question is naming.
Yeah.
But before we launch into names, though, so the other case, which I think we need to think more about because it partly relates to the next item, which is kind of a big topic, is there are some. Well, this is a complicated topic that really needs to go along with this one here. But basically, there is a model in which we'd like it to be possible to create certain very low-level data types, like C arrays and stuff like that. In which case, this would probably be the function to do that. But
wait a second. So this function, you're saying normally foo would be a type that you have declared.
Yes.
And it has certain parameters. The type has certain parameters. In this case, it has fields and things like this.
Yes.
That have been defined. Now you're saying a C array might be something where the only parameter is the length of the array.
For example, yeah.
Although doesn't a C array have to know its base type?
So yes. So basically, I think right. So
I mean,
in this case,
probably fill it
can infer its argument type. You could write this if you wanted to, but you probably wouldn't have to write this because it could infer the argument type.
By the way, did we implement the : bracket thing?
I don't think so.
Okay, right, but conceptually it's that.
Yeah.
Okay, what's incompatible between those two things? I mean, that's just in a sense,
nothing. I mean, it's basically just this is the type of the thing you'd like to create, and these are some arguments that specify how to create it.
Okay, so there's no issue with the payload being different from parametric arguments there. I'm
just bringing this one up because this is a case where it's not a user-defined function, or it's not a user-defined type. I mean, and the argument structures could be kind of arbitrary.
Right. Right, but okay, doesn't seem problematic.
There is another angle on this, is you could create this with a stack allocation instead of a heap allocation. I mean, maybe that's too obscure, but
let's think about that for a second. You're putting this on the stack.
Well, I'm collecting memory from the stack. So I
understand that, but I mean, you're at the level of C code, you would be just, that's some kind of ampersand-y type thing. You passed something in. Is that right?
I think that the issue is, okay, so it's the way that our, say, struct types work right now is when I create this food type, it's actually secretly a pointer.
Right.
And it could secretly be a pointer to memory on the heap, or it could secretly be a pointer to memory on the stack.
I think that's good. I think that's good that it's like that.
Right. But so I guess the only reason I think you really want to have it on the stack is either A, if you've explicitly disabled automatic memory management because you know that you know it's only going to be used in this function and you think it's more optimized, and B, just that it's more optimized because it doesn't have to do with heap allocation.
Yeah.
I mean, in C, right, the way you declare that, you have to declare, you can't have an arbitrary-sized array on the stack. You'd have to say int, X.
Actually, now you can. In newer versions of C, you can dynamically allocate on the stack.
I see. What does it look like? Is it some kind of smalloc or something?
It's just array of, you can just do array of X, where X is like a variable.
Yeah.
That is passed to the same function.
Or it would be
But it's passed to the same function, right?
I'm not sure what you mean by it's passed to the same.
But where did the
function.
X come from?
I could just write X equals, Fibonacci of 100 or something, and then int array of X.
So something that's not known at compile time, basically.
Yeah.
Okay, fine. But
then
then
the other case for the structs, the case is, if you do struct foo, this isn't quite correct C syntax, but if you just do something like this, it's a semicolon, I think.
Normally it isn't a struct, yeah. Or at least it was.
I'm missing the type def that you need to make this actually usable. But ignoring that, the two ways you do it, if you were allocating it on the stack way, would be you just write foo, my object, and then later you write my object dot field one equals blah blah blah, etc. Right? So it's just you just write this, and that just says that you want to have it on the stack. And on the heap, you would do my object, or you do you must have it as a pointer. Foo star, my object equals.
Right. Right, I understand. But for us, if you do something on the stack, what does it look like? I mean, how do your inside? It
pretty much looks identical. It just looks identical.
Okay.
The only substantive difference is that you have to be a little aware of what you're doing because you can't return it. Like it'll crash your kernel if you return it from a function and it gets used.
But presumably we detect that in the compiler and don't let you return it.
Well, this is, by the way, different.
It's uncomputable in general, of course,
Right. I mean, this is, by the way, right. This is also an issue with the two-pointer, from-pointer stuff above, is that right now, we don't really have any escape analysis stuff. And of course, like Tom was saying, you can't, it's fun, it's ultimately undecidable. You can't.
Actually, you could call an external function and you don't know what that does. So,
well, right. I mean, there's that case, but even in code that you write, just
but
using
even in code that you see that you have, you don't know what it does.
Right. I mean, this, by the way, there were some ideas that maybe need a little more time to get figured out with this unmanaged or managed or whatever it's called thing, which might resolve some of that. But
okay, but so the issue here is for this thing that is being allocated on the stack. On the heap. But you might want a version that's allocated on the stack as well.
Maybe that's too obscure. So
I don't think it's too obscure. I think people are going to want that.
Okay.
I mean, the only reason to do it is for optimization.
Yes. Well, that's.
I mean, isn't there also, Tom? Isn't there a thing of you can specify in the type declaration that when this thing is created, you like it to be on the stack? Or no, sorry. That's
no. That's something different
versus value.
That's making it a value, not a reference thing. You see.
How is that different though? Like if you write something like this, isn't this equivalent to the value version?
Yes. Well, what you've written there isn't quite right because then you would refer to the address of my object after that. So then you would
But
have.
I mean, if you wanted to, if you wanted to do effectively the same thing of just, I want to have the speed up of not having to do a bunch of heap allocations by setting this to be a value, value semantics.
Right.
Doesn't that get you the same thing?
No, because one is because one's an address and the other is the thing. You see.
I mean, right, but I mean, I'm just saying.
What you've written there,
speaking, most of the time,
there is the my object is sort of you've got the whole thing there. You could return that my object from the function. That would be completely valid. What you can do is address and return the address from the function.
Right. The question is, why would you want, if you could do it this way, aka the value semantics way, why would you ever choose not to do that and instead to do the stack allocation way? Because as far as I can tell, the only real difference is if you then call foo,
very large. So if you're parsing it, if you're supposing it had 1,000 elements, then everywhere you're using it in your code, it's taking up 1,000 elements.
Well, no. But the version that just that's allocated on the stack but has reference semantics, you already can't pass that anywhere because I don't know if the memory
pointing at the stack.
Actually, I guess you can.
No, you can.
You pass it further down if you go further down in the stack, in the stack of stacks, so to speak.
Yeah, I guess it is. It is safe.
Yeah, and you can return it. So.
Wait a minute, you can't return it when the stack has been unwound.
You can return it from this function. You can't return it from this function.
You could return my object from the function. As it's written there, you could return it.
Yeah, because this is the value
because
semantics
C
version.
makes a copy when it does
the return. It would copy it back. This is how input complex numbers, for example.
Mm-hmm.
Right. I mean, this is the value semantics. That's because I've written this in the value semantics way.
Yeah. So it's not a reference. You don't have an address. If you do size of this, you have the size of all the elements rather than a pointer.
All right. So the thing we've got here, we've got this question of this name of the create compiled objects.
Yeah, I think that's the main question. I think the stack thing, maybe it's worth having, but it's definitely a more niche feature. I mean, it's not. It's a third argument or an option or something like that.
Created on the heap is the main thing.
Actually, let me suggest a name. Create type instance. Isn't that what it is? Because it's going to be given a type.
Create an instance of a type. Let me think about that. It's slightly confusing because there's an internal thing that the top level version of it is going to have a different name, but the internal thing is called type instance and has nothing to do with this. But yeah. I mean, at some level, everything has a type. So create type instance is a little bit like saying create object instance. It's like, as opposed to what, well, of course, the instance is going to have a type.
Hang on. The virtue of having type instance there is the first argument is a type.
Yes.
And the create instance thing is overloaded. So you don't need to give the type. It's a way of doing polymorphic object creation. See, this thing is not polymorphic, you see. You have to give an actual type in this.
Right.
Okay, yeah, sure.
And that's kind of a key thing. So yeah.
I'm promoting create type instance. Now, various people, let's see. Richard is commenting that this is like move semantics. I've never heard of move semantics.
That's this stuff with the value versus reference semantic stuff. Yeah.
Why is that called? Well, I thought it was called by value, called by reference, etc. Where did it get a move? Okay, the motivation for stack performance, Richard says, for the stack is performance. What about different evaluators, allocators rather?
Allocators. Yeah. I mean that's reasonable.
Well, you mean like I've written my own evaluator. Please use this one.
Well, no, there's a question. I mean, as Richard's pointing out, linear versus pool versus, I mean, how do you fit in the blocks that you're trying to allocate, all those kinds of things? Because you might know something.
Right now, it's just we've made a choice. I mean, just as malloc, you can write your own evaluator, but if you just call malloc, it's going to just do something.
Well, no, we're not. We're calling it
No, we're not calling
malloc,
malloc.
which
No,
is
we're
which
calling
Mark
the
has spent a
kernel
lot of time making super optimizing.
Yeah,
It has size tables and pools and all this stuff in one.
And it's consistent. You can allocate in compiled code and free in the kernel. I mean, obviously that's useful, you see. So
yes, that is very
but,
useful.
but I mean, I'm just saying that I think that the case of in my particular use case, I've realized that the default evaluator is suboptimal in some way, and I've written my own allocator. I've written my own allocator, or I've gotten my own allocator off a shelf somewhere. I think that's a pretty niche case.
Yeah, that's very niche. Yeah. By the way, Dan on the live stream is commenting on the following thing about stack allocated versions of an instance being just type of foo, sub value, field, whatever. I'm not sure quite what the type.
So that's kind of what we have. It's kind of what we have for the compiled expression stuff. So this is again, this is if you define this low level, C style struct, this is what you're going to have to do. But for compiled expressions,
no, that's the declaration. But I'm
no. But the way that compiled expression declaration does it is if I do this, right, and I say it takes an integer 64 and a real 64, the way I instantiate this secretly, this is defining a struct like this, and the way you instantiate it is just by doing this.
Right. So.
Right.
Okay,
which
but
is
the question,
kind of like what he's saying.
The point that they're saying is it's type, just having the full sub-value thing of a type specification there, although we don't really have that. It will be like a typed object of the type, or typed as suggesting typed instance. Well, type specifier is a higher order type.
Yeah, or like typed. Or
well,
like,
they're suggesting typed instance or type instance of foo of that.
Although it has to be the association.
Yeah, fine. The association there, that's the payload.
Or whatever arguments.
Right, but it could be
type. It's funny because this is a little bit like the internal thing that currently does this is basically this syntax, but it's called compile back to community.
But it doesn't have an association. But yeah, it's a function.
No, let's say the type instance of C array, 12, for example, would be. But I don't quite understand. Type instance would be something. Yes, that would be the stack version of this, because that just is that object in the code.
But then, what does it mean to apply it to its fields or whatever?
Well, no, that's just creating an instance.
But I mean, okay, so you wouldn't have this. You just write that, and that has it uninitialized. Because I think that the point is that
I see what you're saying. But you might be able to say type instance, the initialized type, that thing, that symbolic.
But I mean, you could just as well. I mean, I'm just saying this syntax is the same as this, because you could just as well write this, without the. I mean, I'm not sure if we want to allow that, but if we're allowing uninitialized stuff, you might as well just write that. I mean,
yes, but that allocates on the heap, whereas that other thing, that type instance thing, would just return a handle to the type instance.
Right. In both cases, though, you realize that these things have they can have reference semantics.
Yeah, they're all reference objects.
Right. Well, then these look identical. They look identical. Like, and every function you apply to them is absolutely identical.
Okay. So then question: why is it not just called that type instance of foo? Just represents an instance of the type foo. A blank instance of the type foo. Type instance of foo, comma, some association would represent a filled-in instance of the type foo.
So this is exactly the same as create type instance.
I know. So I'm just suggesting, should it just be called type instance? Why does it need to create?
It could be. Yeah.
I mean, okay, I'm just trying to understand. We don't have to explicitly free it, do we? There's no delete object.
Okay, so this kind of is where we get into this business. So, okay, so by default, I think this should be set to have automatic memory management, and so no, you will not have to free it. if you're interacting with an external program, or in certain other cases, you will probably want to disable that. So that this is the raw struct, in which case it will not be memory managed. Another case is C arrays. C arrays are just not memory managed. And so you will have to free those. So the way that, I mean, there are various, there's some schemes for how to deal with that.
Could we talk? I'm getting completely tired, actually. I mean, it's quite late.
Yeah, and I'm late for something else as well. But yes, what
I think these are
when you say can we talk, you meant, Tom, can we untalk?
Well, can we talk another time? Is what
I see. Okay.
I'm tired.
Right.
But this is all very useful, actually.
How much further do we? Was there a bunch more stuff in this agenda?
Not really. So the main things are this unmanaged stuff, then the return type stuff that we talked about briefly last time, which really just needs a name, and then the wherever it went, the Paclet stuff, which is probably going to be a.
I think we should talk about that a bit more.
What is the Paclet thing? Because I was just having a big meeting about the Paclet repository earlier.
Okay, well we'll have spoilers that might change, tentative spoilers. I mean, basically, it's something like this where, basically right now there are these things called compiled components. The name is maybe up for discussion, but basically the way it is in the Paclet info file, you can specify the extensions that your Paclet provides, like, oh, I provide these symbols, I provide a library or whatever. One of the things you can tell it provides is I provide, the graphs component or whatever for compiled code. And so, right. And that way, when you write, function compile, or when you create a compiler environment, you can tell it, by the way, I need this component or something like that. Sure. But that's sort of one aspect of it. The other aspect is that basically there are these two, you'd like to be able to specify when you write a Paclet, you'd like to be able to also specify top level functions that you'd like to have, available from the Paclet, but which are written in compiled code. So basically this is something where you sort of register various functions that you'd like to have in your Paclet. And then at some point you call build, and that will run the compiler and it will create some library and it will basically, build your Paclet. And then there's, ways of loading it and so on. So yeah, it's a bigger
exciting, but for another
discussion.
time.
Yes.
Yeah.
Right. Sounds good. Great stuff.
Yeah.
Well, this is by the way, presumably a bunch of things are going to be in for 13.1. Is that a true statement?
I think a lot of things are going to be in 13.1. Yeah, why not?
And I think pretty much almost everything that we've talked about here, I think can be in 13.1.
Yeah. That's quite
Wonderful.
soon, Professor.
Right. This is great. Okay.
Good.
All right.
Excellent.
Thanks a lot, guys.